Good evening, students. कैसे हैं आप लोग? Okay, so shall I start with this chapter? Is my voice audible? Hi Sanjeev. Hi Selva. Please confirm if my voice is audible. Okay, so let us start with this chapter, a very interesting chapter. Initially, we will be understanding what electricity is, how electricity is relevant for all of us. Mainly, it is considered that electricity chapter is relevant for only 9th and 10th students, but that is not the real case. Electricity is a must. Okay, thank you so much. Thank you so much. My voice is clear. So, electricity chapter is for everyone. Even if you are a student of science, whether you are a teenager, whether you are an adult, a parent, a class teacher or someone else, electricity is one of those chapters which is very interesting. Why is it so? We will be understanding that in further slides. Apart from that, it is also very important from your half yearly and board examinations. So I will be asking many questions and we will be clearing so many doubts. Not just the numericals, we will be clearing many concepts as well. So let's dive deep into this. So the very first question, is electricity important? Why do all of us think? You don't have to see this picture, I just put it down. So the question is electricity important? The first question. And why is it so important? Yes, I'll be reading your answers. Why electricity is so very important? What are those major challenges which electricity has solved or it is promising us to be solved in the future as well? Every one of you must be aware about the AI, artificial intelligence. Yes or no? Generative AI, Chat GPT, Google Gemini. Google Gemini is also very prominent in these days due to that sari and all things. Most of our mothers and wives, our wives, not your wives, they have been revamped completely and are looking very gorgeous in those with the help of that AI. Apart from that, also we know about machine learnings, robotics, and so many things. My very important question, do you think anything of those could be possible without the power of electricity? If electricity is not there, can these things would be possible for us? Or any future technology without electricity, do you think that would be available to us? All the researches, everything, most of the things will be nullified. So let us now look at this slide, a very amazing slide, that with electricity these are the things we do have, and without electricity these are the things we do have. Like I have put Wi-Fi is there, power lights are there, running water, those things are there, refrigerators, gas, electric oven, so many things are available due to that. If we consider the counterpart of these things without electricity, so Wi-Fi connection, I don't know, maybe telepathy or maybe something else. If you're talking about light bulbs or other things, then candles are available to us. Most of us would be in the night, we would be those stones we do have, no, those produce the spark, and due to which we are able to produce some fire. We would be engaged in those activities. So that is why we know that electricity is so very important. What is the next question which should be coming after this? Yes sir, we understand that electricity is playing a very keen role into our lives. So what's the next question? The very next question is, how is it produced? And this question is not available in your books, but I think, and I know that all of you think as well, that this is also very relevant thing to ask. If you are understanding about electric currents, if you are understanding about charges, if you are solving different numericals about those things, so initially, at least for the sake of our imagination, for the sake of our understanding, for the sake of the clarity, we should be able to understand that why and how the electricity is produced. The very basic question. I don't want to take you very deep into this, but at least basic aspects should be clear right away. So please be with me. We will be focusing on this particular diagram. So first of all, we need kinetic energy source. What is kinetic energy source? We all know that anything which is moving energy, so moving energy is known as kinetic energy. So what sources could that be? It could be fast running steam, it could be combustion gases, it could be water which is flowing very rapidly, it could be fast flowing winds, and we all of us know, and later on I will be showing that thing to you as well, that our power plants also are using these sources. Also we know, also we talk about these as fuels. So these will be talked upon there. So initial thing which is the keen requirement is kinetic energy source. The first thing. Now what happens? It is that source is directly immersed into a rotor, and rotor is, this is the entire thing. This entire thing is known as electric generator. We know there are two things. One is known as motor and second is known as generator. Just understand these things. I don't want you to remember much about this, but at least understand the entire flow, entire concept of electricity production. So there is a difference between motor and generator. Motor is something in which electricity or electrical energy is being passed to a device that is known as motor, and what we are getting kinetic energy. Can we have some examples? So many. Electric fans, coolers, even your air conditioners. If you can find a small fan in your computers as well, in CPUs as well. Even laptops are also having those fans. Nowadays also that thing is not further required. So about motors we understood that there is an electrical energy which is in the form of electricity that is passed through a device which is known as motor, and ultimately what we are getting outside, we are getting a kinetic energy. That is the use case. if we reverse this thing, if we are putting kinetic energy to a device, and ultimately what we are getting electrical energy. So the device which is able to perform this very activity, the most keen activity, that device is known as generators. Are you with me? Okay, so this is what a turbine electric generator is known as. Turbine is something like a fan, a big fan. So this is, you can see there is a rotor shaft and other things are there. So what happens once this electricity is being produced? It is directly submitted to the towers, these electrical transmission towers. I have a few slides about that also, and ultimately it is distributed to our homes. Similar use case is there as well, almost a similar use case. Chemical energy is converted into very hot steam. What is steam is acting like? Yes, washing machine, exactly, washing machine as a use case. So steam is acting like a very fast moving thing. So what is it is producing? This is rotating the rotor of a turbine, and ultimately what we are getting, the same process. So now we are moving to the next step. These are some ways in which electricity is being stored. This is the way electricity is being transmitted. So there are some power generating stations, I will be showing that, and from those stations electricity is being transferred to a step up transformer. A step up transformer, you can understand, there is a step down transformer in our localities. Most localities are not having those in these days. So you must have seen that there is a very big device, and those device which is always making some kind of noise, weird noise. So those devices are known as step down transformer. I won't be getting deep into what is step up and step down. So what happens? Power generating station, the power is transmitted to a step up transformer. Ultimately it is to different transmission towers, and finally after going through all these phases, it is returning to our homes. This is the entire journey. Now these are a few types of transmission towers. So when we are writing, V means voltage, and when there is small kV, that is known as kilo voltage. So this is how the transmission happens. You must have seen these kind of towers in your homes as well, hai na? Okay. So are you enjoying this thing? Are you enjoying this journey of concepts? Please write happy in the comment box. I want to know that all of you are happy by understanding these very concepts. Okay, so now we are going further as well. These are the power stations. These are the places where the kinetic energy source and ultimately the entire transmission process is being processed. So there are various kinds of power plants, like I have mentioned over here, nuclear power plants. We know about nuclear power plants, hai na? Can you please name me just one fuel of nuclear power plant? Just one fuel. Thank you so much for your comments. Thank you so much. Nuclear power plant, a very important power plant. Thank you so much, Sanjeev. Uranium, yes. Do you know what is an isotope? Okay, that will be much deeper. Okay, thank you so much, Selva. Yes, uranium is one of the fuels of these nuclear power plants. So there are so many other power plants as well. Like there is natural gas power plant, which is generally situated in the villages. Yes, thank you so much, Archana. Yes, uranium 235. a very important isotope which is generally used in nuclear power plants. Thank you so much. Sarda, this is not uranium 230, this is uranium 235. This is one of the isotopes. Okay, thank you so much. Now continuing the chapter further. So these are a few power plants: coal power plant, geothermal, hydroelectric, wind power plant, solar power plant, and so many others. So now coming to the chapter which is being asked in your syllabus. So this is our chapter. These are the basic things which we have to understand. Yes, Shweta, thank you so much. Yes. So we will be understanding about a few concepts in this chapter. First of all, there is electric charge, the Q. We will be understanding about that. There is resistance, current, voltage or potential difference, electric power, and we will also be understanding about a few circuit symbols, and we will maybe today only I will be discussing about a few circuit diagrams with you, and the type of questions which are being asked in your examinations, and later on we will also be understanding about the electrical consumption. Are you with me? So let us start with very basic thing, the types of charges. All of us know that there are generally two types of charges. One charges are positive and one charges are negative. And we have read about those. Also we know that the opposite charges, I mean the positive and negative, they would be attracting each other. The positive and negative would be attracting each other, and what will happen to the similar charges or the like charges? They will be repelling each other. So now understanding this flow of charges, please look at very keenly about this diagram. What is happening over here? The electrons which are charges or the negative charges, they would be moving here and there without any potential difference or without any voltage. What is voltage exactly? You can consider a voltage as a cell or a battery. Initially, this we can consider. So when there is no voltage applied to a conductor, the charges inside that conductor would be roaming around in different directions. So what will happen if I apply a voltage or a potential difference towards it? Reminding you of the fact that any potential difference or a voltage would be having two terminals. One terminal would be positive terminal, and second terminal would be negative terminal. And in the last slide we have learned that opposite charges would be attracting each other, and like charges would be repelling each other. So now coming to the concept, if I would be applying a positive terminal of battery or a cell here and a negative terminal of the battery or a cell here, so what do you think would be happening? Electrons are negative charge. The negative terminal of the battery would be repelling those electrons, would be repelling these electrons, and the positive terminal of the battery would be attracting those that come to me. So there would be a net flow of electric charges. This flow later on will be known as electric current. A very simple concept. What is happening initially when there is no charge, no cell or battery? The electrons are roaming around. When there is no teacher, what is happening in the class? You people are roaming around. Someone is roaming over here. So this is happening. When a teacher comes, so what happens? Those who were negative particles of the class, they get repelled, and they become the backbenchers of that class. And what is happening? The ones who are nice fellows, they are attracted towards the teacher. So this is about the flow of charge. You have to remind this concept. Now one of the very important concepts is conductors and insulators. These are electric wires. So the wires inside this is known as plastic cover. We know that wires are conductors. You must be saying, sir, we already know these things. But still, we have to cover all concepts over here. And the outside thing is insulator, and the inside wire, that is the conductor. Similarly, we can see in the 3-pin plug. These are metal pins, the conductors. The outer case or the plastic case, that is known as insulators. So this is how your entire thing is. Okay, so are you guys ready with first numerical, first question, the opening question, the pilot question? Very simple question I am going to give you. I am repeating this question. You have to calculate the number of electrons constituting 1 coulomb of charge. There is a charge 1 coulomb and we need to find out the number of electrons. Very simple question. This question doesn't require any formula as well. This is simple mathematical calculation. So I need your answers. Okay, Sanjeev is telling that D is the correct answer. Okay, most of you are telling that D is the right answer. Okay, let us see. We know that one electron is having charge of, what is the charge on one electron? Please write it down. What is the charge on one electron? So this is the charge on one electron, 1.6 into 10 raised to power minus 19. So question is, we need to find we need to understand that how many electrons are there in 1 coulomb of charge. These questions are very important, and please let me know how many of you have problems in such kind of problems, such kind of questions. Please be very frank with me. Shweta, this is negative, but I want to know what is the value of that thing. The value I have already written. The value is 1.6 into 10 raised to power minus 19 coulombs. Are we facing some kind of problems in these type of questions? Okay, let me try to resolve that. So the question is, we need to understand 1 coulomb of charge, how many electrons? That is 1 coulomb, how many electrons? Very simple thing. So it is just the counterpart of this equation. So if I write it as 1 coulomb and divide both sides by 1.6 into 10 raised to power minus 19, so it will come, it will be divided by this equation, so it will come as 1. Ultimately we will be getting as 1 coulomb. Yes or no? And we know a property in maths that 1 upon 10 raised to power minus a is known as 10 raised to power a. We will be using this very property, and it will become 1 over 1.6 into 10 raised to power minus 19 would be becoming 10 raised to power plus 18. And here we are having 1 coulomb of charge. From this 10 raised to power 19, we are taking just one value of 10. One value of 0, and it will become as 18. So what will happen? This will become 6.25, and yes, all the answers are correct. Thank you so much. Now moving on to the next concept. So we know that there are two types of electricity. There are static electricity. The example you are already seen. How many of you have seen Mr. Bean? Mr. Bean series. Any fans of Mr. Bean? Rowan Atkinson. By the way, Mr. Bean, the character, the personality, Rowan Atkinson, who is playing Mr. Bean, he is also happened to be an electrical engineer. So in one of his program, he was using the concept of static electricity. But static electricity, just we will be touching this point. What is exactly static electricity? So as you can see, it is something with the electric charges at rest, है ना? And the current electricity, which we will be discussing in this chapter for your class 10th, this is about the charges in motion, है ना? Rest means charges are taking must rest, and when in motion they would be in motion. So the current electricity, current is also known as something in motion. We know water current, we know air current, we know different kinds of current. Whenever the current term is used, the exact meaning of current is anything which is moving. So here you can see this is a one-time event, static electricity, and current electricity is a constant flow. For example, if we are switching on a fan, so is it a one-time event? It just moves for a second and then stops. It is not the case, na? It moves continuously till the electricity is there. So that type of electricity is known as current electricity. And in static electricity, the charges are built up on a single side, maybe on any single location. And in current electricity, there is a constant flow of electricity is there, or constant flow of electrons are there. So with this information, we would be understanding about a few concepts. We know that a very important term, the rate of flow of charge, we have already discussed. This is known as electric current, the current electricity part. Static electricity we won't be discussing in this. That will again be coming in your syllabus in class 11th. And it is denoted by a symbol I. It is basically amperes. And the value is very simple. I is equal to, that is current is equal to charges upon my time. And we would be here we need to understand a few concepts apart from this as well, that the multiple units and sub multiple units, two things are there. Whenever we say multiple units, the meaning of multiple, I am assuming that all of you are taking notes. Please, I need a yes from you all. I am assuming that all of you are taking notes of this lecture. Thank you so much, Mahesh. I think all of you are taking notes, right? Please guys, it is very important that for the every chapter or every topic, we are having some notes with us. It becomes very important. Okay, so now moving ahead. So when we talk about the multiple units are the powers of tens in positive direction. Let me give you an example. If there is a term 1, and if I am talking about the multiples of 1, then it would be 10 raised to power 2, or maybe 10 raised to power 3, or maybe 10 raised to power 16, or maybe infinity, whatever value is there. And when submultiple values are there, so submultiple things are in the negative context. 10 raised to power minus 2, 10 raised to power minus 4, 10 raised to power minus 16, similarly. And so I hope you understand this concept. Now coming back to this, a few terms which you should be knowing. One is kiloampere or a kilo thing. So whenever K is there in front of ampere, in front of voltage, in front of watts, or in front of resistance, or in terms of any other SI unit, So it means that we are talking about 10 raised to power 3 kilo or 1000 times. Clear to us? Whenever we are talking about mega, so mega is 10 raised to power 6, that is a million. We know a million, no? Million is 10 lakhs. All of us know that, all of us have a deep desire that there should be 1 million subscribers to us. There would be so many subscribers. By the way, talking about the subscribers, I want all of you to subscribe this so that you are not you are able to have all the lectures, all the lives which have been delivered to this. So kindly subscribe as well. So mega ampere is known as 10 raised to power 6. Now coming to submultiple, when we talk about milli, so milli is 10 raised to power minus 3, and microampere or micro thing is written as mu, so this is 10 raised to power minus 6. So we have discussed about 4 things: kilo, mega, these are multiples, that is positive; micro and milli, these are negatives. And we have understood that I is equal to Q over T. This is our formula. Coming to the next formula, then we will be having a few examples and a few numericals. Sometimes it is asked that what is the definition of 1 ampere. So 1 ampere, we can say the current passing through a conductor is said to be 1 ampere when the net flow of charge per second through its cross section is 1 coulomb. What does it mean? This is a very complicated definition. No, it doesn't. This is very simple definition. What it is asking, I is equal to Q over T, we already know. Just putting the SI units over here and giving them the values as 1. That is 1 ampere is equal to 1 coulomb over 1 second. Now again reading the definition, and what I am trying to provide you here is all the definition which are being used in physics, especially in your early classes, the foundation classes. The definitions are very simple to be narrated. So what we are asking, the current passing through a conductor. Can we write the current passing, just the current passing? Yes, you can, but when we say about a specific thing, all of you must have heard about the SMART goals. So in SMART goals, the S stands for specific. So we should be very specific when we are dealing with anything. So current passing through a conductor, we are not stating that we are not assuming or let any other assume that it might be passing through insulator or other thing. We are very clear that it is passing through a conductor, and it is said to be 1 ampere when the net flow of charge per second. Why per second? Because it is already given through its cross section. Whenever there is a conductor, I mean, you can assume a wire or you can assume this pen of iPad. So this has a cross section. This is the cross section. So this is very important that these components are there in our definition. I think all of you have understood this concept. Okay, so now moving to the next concept or next formula, we already know that I is equal to Q over T. Now the new formula has been provided to us, and that formula is known as quantization of charge, and that is equal to Q is equal to N into E. What does it mean? Q we already know, N is number of electrons, and E is the charge on one electron, that is 1 E is equal to 1.6 into 10 raised to power minus 19 C. So now let us jump to the next numerical. So these are two equations to us. One equation is I is equal to Q over T, and second equation is Q is equal to NE. So by substituting the values, we can also get this value, I is equal to NE over T, or we can also get Q is equal to I into T and Q is equal to NE. So this equation we can also have, and based on these equations we can solve the further numericals very easily. So here is the next question. A current of 5 amperes is flowing through a conductor or a circuit for 15 minutes. We need to calculate the amount of electric charge that is flowing through the circuit during this time. Very simple question. Kindly share your answers if you have completed this. Sanjeev, 75 watt, 75 amperes, 75 coulombs, 75 ohms. Sarda, what is 75? Again the same question. Okay, 75 coulombs. Okay. Okay, I am moving to a back slide and let us understand about a few things. It was given over here that charges per second, and in the question they have provided us the time in minutes. Don't you think that we need to change the minutes into seconds? Guys, your answers are not correct, so kindly please come up with the right answers. 75 coulomb is not right answer. We need to change this into seconds. Can we quickly get a new answer? The correct answer. Okay, so yes, we have got a correct answer. We have got okay, so now let us see how to complete this question. It has been given to us that the value of I is 5 amperes and the time is 15 minutes. What we are supposed to do is, whenever you are getting a time in minutes, in hours, in days, in whatever form, first of all, for this question we need to make it to seconds. That is the very first requirement. We know that 1 minute is 60 seconds. Putting the value over here, so 15 into 6, it will become 900 seconds. Now already you know the formula, Q is equal to I multiplied by T, and it will come to 5 into 900, that is 4500 coulombs, capital C. A simple question. Very good. Those who have found the correct answer, very nice, kudos to them. And those who have worked on this very concept, again congratulations to them as well. So now moving to the next question, almost a similar question. An electric bulb draws a current of 0.25 amperes for 20 minutes, we need to identify the amount of electric charge that flows to that circuit. Can I ask you, all of you, a favor, please? Can we just focus on this question and find the correct value, the accurate value of the answer, without attaching to the speed? Okay, Sanjeev, thank you so much. I don't know whether this answer is correct or not. I myself have to find it out. Okay, Sweta, thank you. Thank you, Mohini. Let's find out, Sanjeev. Thank you, Sarda. Okay, I think 300 would be the right answer because most of you have found it out. So let us start with this question. We know that I is 0.25 amperes and timing is 20 minutes, that is 20 into 60, 1200 seconds. Is it right? So formulating this thing into our formula, and 0.25 into 1200, so these two zeros will be covered with this. 25 into 12, yes, it will come out to be 300 coulombs. So everyone has correct answer. Thank you so much. Very nice. I'm so very happy. Shall we move to the next question? Okay, so this question has two parts. You will be providing me the answers as A, answer this, B, answer this. I am repeating the question. A TV set shoots out a beam of electrons. The beam current is 10 micro amperes. Please focus on this term as well. The first question is, how many electrons strike the TV screen in each second? Question number 1. Question number 2, how much charge strikes the screen in 1 minute? Simple question. Please focus on the value of current. This is a submultiple value. I'm still waiting for the first answer. Okay, Sanjeev. I don't know whether this answer is correct or not. We need to find it out. And let me thank all of you. You guys are really amazing. Seriously. One big shout out to all of you. Most of the answers which you have calculated are absolutely correct. I don't know about this, Sanjeev, but yes, I am suggesting this thing on the basis of your previous answers. So very happy to be with all of you. Okay, Sanjeev. I hope everyone understands the question. Okay, Shweta, you have provided me your first answer. Okay. Yes, Sanjeev, I have got your both answers. Okay, let me just provide you the formulation for this. Let us see that all of us are on the same track. So the value of I is 10 microampere. The very first thing which is required is, thank you, Sweta, I got your both answers. So we know that 1 micro is equal to 10 raised to the minus 6. Putting this value over here, 10 into 10 raised to the minus 6 amperes. This is our I. Hope everyone is with me. Okay, now coming to the question. How many electrons strike the TV screen in each second? When each second term is used, so each second means 1 second. So the timing would be 1 second. And so we need to find how many electrons. The formulas we do have, Q is equal to I into T and Q is equal to N into A. But we are already having, we are having I, we are having T, we know the value of E, we need to find out N. Simple, let us find it out. Now putting all these values over here, 10 multiply 10 is to the minus 6, the value of T is 1 second, the value of N we are not knowing yet, and E's value is 1.6 into 10 raised to the minus 19 coulombs. Now keeping this to the right hand side and moving all other values to the left, it will become 10 into 10 raised to the minus 6 over 1.6 into 10 raised to the minus 19. Now calculating for these values, the powers, this we already know, this is 6.25. The calculating these values, we know that when there is 10 raised to the power A over 10 raised to the power B, the value becomes 10 raised to the power A minus B. So working on this, so 10 raised to the power minus 6, this will come upon and it will become plus 19, so it will become 10 raised to the power 13. So our correct answer of N, that is number of electrons, would be 6.25 into 10 raised to the power 13 electrons. These many electrons would be there. This is the first part. So most of you, not most of you, 10 raised to the power 13. Okay. So Sanjeev, your answer is correct. Shweta, your answer is correct. Okay, now moving to the second part. It is asking how much charge would be striking in each minute. How much charge would it be striking in each minute? How would we find it out? Time, we know that time is 1 minute or 60 seconds. I, we already know that is 10 microampere or 10 into 10 raised to the power minus 6 amperes. But we are supposed to find it, we need to find the value of Q. So Q already is known, I multiply by T, and the value would become 10 into 10 raised to the power minus 6 into 60. So the value is going to be 6 into 10 raised to the power 2. I have taken these two apart, multiply by 10 raised to the power minus 6. Calculating these two values, it will become 6 multiply 10 raised to the power minus 4 coulombs, capital C. This will be the charge. So everyone understood this concept? Anybody tired? Or shall we take one more example, one more numerical? Okay, so last numerical for the day. Very interesting numerical. After this, your concept relating to electric current, quantization of charge, how we need to find the number of electrons in a question, the amount of electric charge, everything will be resolved. The question is, a current of 10 ampere exists in a conductor, assuming that this current is entirely due to flow of electrons. First we need to find the number of electron crossing the area of cross section per second. Everything is given. And second is, if such a current is maintained for 1 hour, find the net flow of charge. Almost the similar question to the previous question we were we already know the current, we already know the time, we just need to find the number of electrons. The equation is already known to us. Okay, Sanjeev, thank you so much for your answer. Okay, Selva, thank you so much. Thank you, Mohini. Thank you, Sanjeev. Thank you, Sweta. 0.6 into 10. Thank you, Mohini, for the second part. Okay, so let us find the first part. Current is given to us as 10 amperes and time is given of 1 second. And we need to find out the number of electrons. Okay, so we already know the question. We already know the formula for this. We know that Q is equal to IT is equal to NE. By putting the values into this equation, I is 10 ampere, T is 1 second, and we need to find it out. And this is 1.6 into 10 to the power minus 19. So by substituting this value, 10 over 1.6 into 10 to the power minus 19 is the value of N. So this we already know, this is 6.25, and this will come up upon and it will become N is equal to 6.25 into 10 to the power 19 electrons. So Sanjeev, Selva, Mohini, Sweta, all answers are correct. Thank you so much, guys. So now moving to the second part. If such a current is maintained for 1 hour, the new time is given to us 1 hour, that means 60 into 60 or 3600 seconds. We need to find net flow of charge. We need to find the value of Q. We know the value of Q, there are two values. One is NE and second is IT. So for this question, we need to find it from the IT value. So Q is equal to, I is already given to us as 10 amperes and this is 3600 seconds. So it will become 36,000 coulombs. So this will be the answer, or it could be written as 3.6 into 10 raised to the power 4 coulombs. Both answers are correct. So Mohini's answer, Selva answer, Shweta's answer, Sanjeev's answer, all the answers are absolutely correct. So now just a quick recap and a pre-cap for the next session also. What we have done in this entire session for 1 hour. So initially we started about the importance of electricity, that what will happen if electricity is not there. We started with this very concept. Then there was a very important keen question in all of us, that how is it actually produced, and we have understood this concept with the help of kinetic energy, electric generator, the difference between a motor and a generator, how is the basic functioning of these two devices. Later on we also understood how the electricity is being transmitted ultimately from a power plant. From a power plant, how is it transmitted to our homes? We have understood this also. These were a few types of transmission towers. These are a few power stations, or these are also known as power plants. We have understood about the charges, types of charges, the flow of charges, how a battery or a potential difference is changing or narrating the direction of flow of charges. So we have understood that also. A difference of conductors and insulators, basic problems about static charge, Mr. Bean and static charge, the concept of electric current, and the very important thing of multiple and submultiple units. We have understood the concept of specific, whenever we are talking about a definition, especially in the physics, so that definition should be specific with the help of SMART goals. Also, we found out a new formula, quantization of charge. Then there are this equation, the new equation which we came upon, and then ultimately we have understood these numericals. So these were the recap of this session. In the next session we will be talking about ammeter, voltmeter, galvanometer, what is the role of electric circuits, how those circuits are to be connected. Can we, just by seeing the electric circuit diagram, can we understand that this circuit is going to be correct and this is going to be incorrect? So these very basic concepts we will be understanding in next session, and the timings for that session would be provided to you. Thank you so much for being so kind and so enthusiastic during this entire session. Good night, take care, bye.